Hi, fourth grade. Today we are going to work on 4 word problems from 2.3F. For this lesson, you are going to need your math notebook, a scissors, glue stick, and a pencil. You also need your sheet of paper with the 4 word problems on them. You picked that up in your pile of papers from your classroom, but if you don't have it, I also uploaded a PDF in the folder where you found this recording. So please pause the video and go get those things. Okay, step 1, read the word problem. So, Ellie bought 5 boxes of cookies for $8. How much did 2 boxes cost? Step 2, we need to identify the question and rewrite it, leaving a blank for the answer. How much did 2 boxes cost? So, I'm going to write 2 boxes cost blank dollars. Remember, when you start a sentence with a number, you need to write out that number. So we can't just write the digit 2. And I apologize for the messy handwriting. This is the second time I've recorded this, and the first time I actually wrote in cursive, and I thought it was harder to read than the print, so that's why I'm going in print. And you know, given the situation, I feel like you could do print or cursive. Either is fine. All right, step 3. We've got to say what's going on in this problem. What do we know? Well, we know there's this girl, Ellie. We know that this probably happened a while ago because there are actually 5 boxes of cookies available on the grocery store shelf. And she paid $8 for all 5 boxes. We also know that we don't know how much each box cost, and we're actually trying to find out how much 2 boxes cost. Now we need to decide how we're going to chunk this problem. You need to decide, is this comparing something, or is this a part whole? And I would say this is a part whole bar model. So I'm just going to draw my bar here. And because we know the number of spaces in this bar, I'm going to go ahead and do that. So we're going to make 5 spaces. And because 5 is an odd number, go ahead and draw a road in the middle of your bar. And then you're going to easily be able to divide the other 2 sections up, and you can get 5 fairly even spaces. These are the cookies. So I'm just going to put a C there for cookie. That's a good song for you to look up. C is for cookie, if you've never heard that. Then you can put a bracket here. And all of these boxes were $8. We need to figure out now where our question mark goes. Put your question mark in. And this is where I'm putting mine. So hopefully yours went in with 2 boxes. And now we need to solve our problem. So we have 5 boxes that were $8. That means we have to divide this $8 up over the 5 boxes. And since we're talking about dollars, you could, if you want, put a decimal mark and then 2 zeros, or you can do it this way. It doesn't matter. Either way, we're going to get the same answer. So if I have $8 and I have 5 boxes, I know I could put $1 in, or assign $1 to each of those boxes, and I would have used up $5. I would have $3 left. And now I'm actually moving to my dimes. Pop your decimal up at the top. Now, instead of thinking of this as 3 $1 bills, I'm going to think of this as 30 dimes. It's the same thing. So 30 tenths instead of 3 ones. 30 tenths, or 30 dimes, divided into 5 groups, is going to be 6 tenths, because 30 divided by 5 is 6. So 30 tenths divided by 5 is 6 tenths. Because fourth grade, when you divide puppies, you get puppies. You will have used up 30 tenths. You don't have anything left. And at this point, I'm going to bring down another 0 here because our answer, we want it in our regular money notation. And so I'm just going to pop my other 0, say I have 0 hundredths left, going into 5, 0 times. So, oh, sorry. So you could do, you could just leave it as 1.6, but when we write dollars and cents, we always have two place values right here, and so that's why I was going to put I put a 0 there. So now I can do $1.60 in each of these boxes. That means that each box of cookies costs $1.60. And then it should be easy from this point to figure out how many 2 boxes of cookies cost. You could do it a few different ways. You could either add $1.60 plus $1.60, and that's the way I'll do it this time. Can anybody think of another way to do it? You could multiply $1.60 times 2. You could even think of this as 16 tenths plus 16 tenths, and then go from there. So 2 boxes cost $3.20. In order to check this, you could do it a few different ways. You could say, well, this is $3.20. That means 2 more boxes would be $3.20, and then $1.60 more. So $3.20 plus $3.20 plus $1.60 should equal $8. 2 boxes cost $3.20. You could also start with your whole, your $8, and you could subtract $1.60 minus $3.20 minus $3.20, and you should end up with 0. You could also check this by doing $1.60 times 5, and you should end up with $8. So lots of different ways to check your work. Put a little star on your paper if you got this one right. Okay, next one. Go ahead and cut out your next one, which is about Taylor. Glue that into your notebook, and then we'll solve this problem. All right. Read the problem. Taylor had $5.40. She has 3 times as much money as Bonita. How much more money does Taylor have than Bonita? All right, we are going to underline our question and rewrite our question, leaving a blank for the answer. How much more money does Taylor have than Bonita? Taylor has, don't forget your units, your dollar sign, blank dollars more than, don't write then, than with that A is comparing, Bonita. And I'm just going to put a B there. Pause this anytime you need extra time to write. I'm just going to keep going. Okay, step 3. What do we know? Well, we know there's this girl named Taylor, and she has $5.40. We also know that Bonita has money, but she doesn't have nearly as much money as Taylor. Taylor has 3 times as much money as Bonita. And we need to figure out not how much money Bonita has, but how much more money Taylor has than Bonita. So in your brain, you should think, is this a part whole bar model or a comparison bar model? And when you see this word than, like how much more than, that should in your brain make some bells go off and you say, ooh, this is definitely comparing 2 things. So go ahead and draw your starting bar. We're going to put a T for Taylor. We're going to put a B for Bonita. And they both have some money. But Taylor has 3 times as much as Bonita. So I need to make 2 more of these, about the same size. It doesn't have to be exact, but just so you can see. What else could we fill in? Well, we know how much this is. This whole thing here is $5.40. Where does our question mark go? They're asking not how much does Bonita have down here. They're asking what the difference is, what this sort of empty space is here between what Taylor has and what Bonita has. So this is what we really want to find out, how much extra Taylor has compared to Bonita. How are we going to do this? Well, we are going to have to figure out how much each of these boxes can hold, and then we could fill it all in. So if we have 540, and we need to divide it equally into 3 boxes to figure out how much each box is for Taylor, then this box here is the same size as this box here, and we could easily put that in for Bonita also. All right, so let's do 540 divided by 3. You can share $5 divided by 3. Each could get $1, and you would have used up 3 $1 bills. You would have $2 left, and we're going to bring down our next place value, which is our 10th place. Now, instead of thinking of this as 2 $1 bills and 4 dimes, we're thinking of this as 24 dimes or 24 tenths. Pop your decimal up here because we're talking about tenths now. And we're going to say 24 tenths divided by 3. Well, 24 divided by 3 is 8. So 24 tenths divided by 3 is 8 tenths. Because when you divide puppies, you get puppies. 24 tenths, we have 0 left. And now we're bringing down our 0 here. And just like in our last problem, we have 0 down here. We don't have to really divide anything else out, but because this is money, we're adding that 0 up here to say that it is $1.80. That means each of these boxes is $1.80. That means Bonita's box is $1.80 also. All right, now let's get back to our question over here. How much more money does Taylor have than Bonita? Well, we could do like last time and we could add $1.80 plus $1.80. This time I'm going to multiply it by 2. So I'm going to do $1.80 times 2. 2 times 0 is 0. 2 times 8 is 16. And 2 times 1 is 2 plus 1 more is 3. And I'm going to pop my decimal right there because I moved over to the ones place. So, oh gosh, I wrote a 3 instead of 1. I'm sorry. So 360 is how much more Taylor has than Bonita. How could you check this answer? Think, think, think. This is where your creativity comes in handy. You could do it a couple different ways. You could say, well, 360 plus 180 should be 540. 540 minus 360 should be 180. Here's a challenge for the grade. How much money in total do the girls have? You could do 180 times 4 because we have 4 boxes that have 180 in them. You could do 540 plus this 180 down here. So either way would work. All right, next problem. This is about Steve. So find your problem about Steve and go ahead and cut him out, glue it on your notebook page, and get ready. Okay. Steve bought 5 gallons of orange juice. After filling up 5 bottles of the same size with orange juice, he had 25 hundredths of a gallon of orange juice left. Find the amount of orange juice in each bottle. So the first thing we need to do is we need to, at the bottom, figure out what we're looking for. And I'm going to use orange because we're talking about orange juice here. So find the amount of orange juice in each bottle. We need to leave a blank for the answer. So I'm going to say each bottle has blank. What's our unit? Our unit is gallons, way up here. Gallons of OJ. All right, next step. We need to say what is going on in this problem. What do we know? Well, we know there's a guy named Steve. We know Steve is dumping 5 gallons of orange juice into smaller bottles. 5 gallons is a lot. When you buy milk at the store, your family probably buys a gallon of milk. So he bought 5 of those gallons. And then he decided that he was going to dump them into different bottles, not gallons, but bottles. And we don't know why he's doing this, but we do know that the bottles, these 5 bottles, don't quite take up all of it because he still has some left. Now we've got to decide, is this comparing something or is this a part whole? Well, we've got lots and lots of parts here, and we also have our whole, which is our 5 gallons. So this is a part whole problem. So I'm going to draw my bar here, and this is all of the OJ. I know what my whole is. They told us the whole, and that is 5 gallons. I'm going to make that go all the way to the end. Now, what are our parts? Well, we have this part, here, that's the 5 bottles, but we also have this extra little part over here that's left over. 25 hundredths of a gallon. How much is that? It might help you to think of this as a quarter, like 25 cents. And so if you think, oh, that's like a quarter of $1. So this is a quarter of a gallon. So this is not very much. Compared to the 5 gallons he has, this is like this much over here. So just make a little bit left. This is his little leftover that he gets. Maybe he'll get to have a cup of juice. It'd be a big cup, by the way, if it was a quarter of a gallon. But it's still small compared to the 5 gallons he had. That's going to be our 25 hundredths. Then, that's one part. And then we've got 5 bottles over here. That's going to be the rest of our parts. So I'm going to switch back my color. And the rest of this bar has to have 5 parts in it. So just like before, 5 is an odd number. So I'm going to make a road in the middle. And then I'm going to divide over here and divide over here. And those are going to be my 5 bottles. Now, how are we going to figure out how much is in each of these bottles? Because that's what we're trying to figure out down here. Each bottle has how much of a gallon. It's not a full gallon because he had some left over here. Well, I think we probably need to figure out what this part is before we can figure out our little question. So we've got a big question and a little question to figure out. How could we figure out our big question, this one down here? If you know, write it down. And I'm going to do it over here. 5 gallons, we could rewrite this like this. That's going to be helpful to subtract because this one has 2 decimal places. So this 5 with a decimal place and 2 zeros does not change the value, but it does help us line up all of our decimals. Now, I'm thinking of this like money, and so I know that 5 gallons minus 25 hundredths is 475. But you absolutely could carry this if you want and cross off. You can cross off the 50 and make this 49 and make this 10 and do 10 minus 5 is 5, 9 minus 2 is 7, and then you have your 4 minus 0 is 4. Either way is totally fine. Okay, now I know what this big chunk is down here. Now I can get to my little one. I'm going to switch colors again. This is 475 divided by, we had 5 bottles. So I do not have enough ones to go into 5 sections. So instead of thinking of this as ones, I'm thinking of this as 47 tenths. 47 tenths. What do I know about my multiples of 5 that's going to get me close to 47? Ooh, I know that 5 times 9 is 45. So 5 times 9 tenths is 45 tenths, because when you multiply puppies, you get puppies. 47 tenths minus 5 tenths is 2 tenths. And then I bring down my 5 hundredths. What do I know about 5 over here and 25 hundredths? Well, I know that 5 times 5 is 25, so 5 times 5 hundredths is 25 hundredths. And I've used up all of my things. I have nothing else to bring down over here. So each of these bottles has not quite a full gallon. It has 95 hundredths. It has like 95 cents, and a full gallon would be $1. So it's definitely close, but it's not quite a gallon each. How could you check this problem? Well, a few different ways. You could do 95 hundredths times 5, and then you could add your 25 hundredths, and you should get 5 gallons. You could just add all these up, 95 hundredths plus 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 25 hundredths. So there are several different ways you could do it. You could start from your whole, your 5 gallons, and you could subtract and go minus 25 hundredths, minus 95 hundredths, all the way down, and hope that you get to 0 over here. So there are lots of different ways for you to check your answer. It's important, though, that you check it. All right, last problem. Find Mrs. Kim, cut that problem out, glue it into your notebook, and then you can unpause. All right, here we go. Mrs. Kim used 4 bags of flour to make 5 cakes of the same size. Each bag of flour weighed 1 35 hundredths of a kilogram. How much flour did she use for each cake? Step 2, find the question and rewrite the question, leaving a blank for the answer. How much flour did she use for each cake? Each cake had, what's our unit? Here it is, kilograms of flour. Step 3, what do we know about this problem? Well, we know there's this lady, Mrs. Kim. We know she must like to bake because she made 5 cakes. And we know that she used 4 bags of flour to make 5 cakes. That means that she didn't use a full bag of flour for each cake, but she did use a lot of flour for each cake. We also know that the bag of flour weighed 1 35 hundredths of a kilogram. And we have to figure out how much flour each cake had. Now we need to ask ourselves, is this a comparative bar model or a part whole? Do we have parts for this? Are we comparing two things? Well, we have lots of parts again. We have several different things that we can do here. I'm going to actually end up making two bar models. The first is going to be my cakes. So let's put a C there. And let's draw our 5 cakes. So again, make a road in the middle and then divide each side. Those are going to be our 5 cakes. Then we need to make a different bar model. And this is going to be 4 bags of flour. The 4 bags of flour we can label here. Each were 1 1/35 of a kilogram. Somehow we have to get all of these guys into all of those cakes. That means that all of this has to be divided up into all of this. And if you could hold this upside down, maybe you would see that, ooh, all of that flour has to be divided up into the 5 cakes like this. And that might look like a number bond to you. We have our whole with our flour, and then we have all of these parts for the cake. So I'm going to quickly erase this so I have some room to work. I bet if we figured out what our whole is, what all this is, then we could divide that whole up among all of the cakes. How are we going to do that? Well, you could either add all these guys up, or you could multiply it by 4. And I'm going to multiply by 4 because I think that is faster. Okay, I've got 5 hundredths times 4 is 20 hundredths. 3 tenths times 4 is 12 tenths, plus 2 more is 14 tenths. 1 times 4 is 4, plus 1 more is 5. So her total is 5 40 hundredths. Then what you need to do is you need to think of this now as your whole, and how are we going to get this whole big bunch of flour into all those cakes? Well, we need to divide that up among the 5 cakes. So we have 5 ones into 5. We can put 1 kilogram into each of these cakes, just like that. We've used up all 5 kilograms. We have 0 wholes left, and we have 4 tenths left. If we have 4 tenths into 5 cakes, we cannot put any tenths in there. We need to actually bring down, so we can do 0 and do this. We can actually bring this down and think of this now as 40 hundredths. If I have 40 hundredths and I need to divide it into 5, think of your multiples of 5 and think, okay, 5 times what is 40? 5 times 8 is 40. So 5 times 8 hundredths is 40 hundredths. Because when you multiply puppies, you get puppies.